Alright guys, this is going to be a video on how to properly set up your rifle for long-range shooting and hunting and the installation of a level specifically into that system to eliminate cant. I've been wanting to put this video together for some time now because I do get a lot of questions about it, and it's a subject that continues to come up on a very regular basis on the internet forums and chat rooms. There's a lot of confusion about it. And there's also a lot of misinformation about what's important and what's not. It's not a difficult process, and this video is going to be fairly lengthy, but I'm going to try and cover all the topics that might come up. So don't get confused thinking because the video is long that this is a difficult process. I'm just going to try and cover the things that are important for reticle shooters, guys that dial, people that want to use certain type of levels, and get all that information out as best as possible. And even if there's questions at the end, don't be afraid to give me an email or discuss it down below in the comment section. And at the end, I hope that it will be very easy to understand, and you guys can get your guns and scopes and levels properly set up and not waste a lot of time, not waste a lot of ammunition, and be out shooting and eliminate a lot of the troubles that you may already be having with your system. So, why do we need a level in our rifle system? Well, if you're only shooting up to 500 to 600 yards, the fact is you really don't. It's not that critical. Error's not that great. For those of you guys that are hunting and shooting at extreme distances or want the absolute most precision you can get, then it becomes a very important issue. First and foremost, at least in my case, is hunting. The terrain is completely uneven. You never know where or when you're going to be shooting from, and it's very easy to have canting and rifle errors. There's all sorts of optical illusions in the field that can trick your eye and cause you to cant the rifle more in some situations than others. And secondly, at long distances, the bullet drift can be really significant. Depending on your rifle and the amount of cant. Let me go to this board here and I'll kind of try and explain it as best I can. No matter what you do, when that bullet leaves the barrel, it falls exactly straight to the earth. There's no twisting, there's no side effects or anything, and this red line is basically drawn on here to show that it basically falls straight to the earth as soon as it leaves the barrel. There's no up, there's no down. The only reason a bullet ever goes up is because we point it uphill. So in this case, you need to understand that the second a bullet leaves, it falls straight to the earth. Gravity affects it 100%. And the only way we change that, and the only way we change so that we hit what we're aiming at, is that we adjust our perceived line of sight with the scope. And in this case, a shorter distance shot would be this upper blue line right here, and we would adjust the scope so that the rifle would point in the direction it needed so that it would impact at that point. And in this case, you would also have your distance above your line of sight would be here to here, okay? And on the shorter distance shot, that distance above your line of sight is not very great. However, when you start getting into extreme distances, you'll start getting out to where your line above your sight is significant. And that's when you start to get issues with cant becoming very significant. But it's important to note that no matter what happens, the second that bullet leaves the barrel, it's falling straight to the earth. Okay? In a properly set up rifle down here on this lower diagram, what will happen is our perceived movement, the gun and the blue is the line of sight here. So we're from behind the shooter's position. And when you fire the bullet, it's going to appear to rise up because we have pointed it uphill, up to its maximum height, and then it will fall back down and then hit our target. So this distance again is that above line of sight distance from at the top of its arc all the way from our line of sight. Now if you have cant induced into your system, you'll end up basically, the bullet no matter what again is falling straight to the earth, but we have to adjust our sights and our scopes so that we hit where we're aiming. If we're off on our cant, let's assume a 10-degree cant or something in this realm, what will end up happening is the bullet will rise up and will fall back down off of that line because we didn't hold it. We leaned the rifle to the right. And what happened is the bullet's not really doing anything other than falling straight to the earth. What we did by leaning the rifle is we have moved our gun's perceived movement. We've pointed it. Instead of pointing it straight up, we pointed it to the right some. And the bullet will fire up and fall down straight in that line. So the distance that it will hit to the right will... It depends on the angle and the height of the line of sight. So the more angle or the larger the above line of sight, the worse a canting error will be. And I don't want to get into a bunch of math or anything about it. It's difficult. I'm not a mathematician, but to put it in general terms, everybody likes to talk at like 1,000 yards, and we'll just do that for the sake of argument. At 1,000 yards, a slow rifle, like a .308 Winchester, with a 6-degree cant. Now, it's important to note that 6 degrees is kind of easy to think about. It's 1 minute. And 1 minute is the easiest way to picture in your mind what 1 minute of cant looks like is literally to point your rifle at a clock or to look at the 1 minute hand. It's not much cant. It's pretty easy to induce that much cant. So we'll work off of that 6 degrees. It's approximately on a slow rifle like a .308 Winchester, the canting error horizontally for your windage will be about 3 feet. Now, when you get into a standard or medium range hunting rifle like a .30-06 or something like that, because it has less line of sight height, it has less arc, perceived arc, you'll end up with a canting error of in that 1 minute range of about 2 feet. Now, when we start getting into our super fast, high performance long range magnums with slippery bullets and VLD bullets and such, you end up closer to about 1 foot of error when you get to that 1 minute or 6 degrees of cant. So that's just a starting point, just to kind of explain briefly how and why stuff drifts to the right or drifts to the left because of the direction you cant the rifle. There's a lot of information on the internet that you can read in much more depth than that, but the fact is I just want you to understand on the slower the rifle, the farther the distance, the worse the canting error is going to be. And you know, in what we're doing for long range precision and hunting, even with the flattest shooting magnums and the slipperiest VLD bullets out there, you're still going to have canting errors of over 1 minute at long range. You're going to have over 1 foot of drift at 1,000 yards, and if you shoot farther than that, it gets even worse. So that's why we need to worry about it in our shooting system, and we'll head that direction now. Okay. There are several different types of levels out there, but they can basically be broken down into 2 categories. The first would be those that are attached to the gun themselves, and those are basically ones that are either attached to a Picatinny rail or a Weaver style base, or attached to one of the rings, and sometimes they'll basically be one that replaces the rear ring cap. Those are somewhat common. The other types would be those that are attached to the scope tube themselves. Now, those come in typically 2 different styles, an offset style such as this Vortex, or a flip-up style such as this scope level. And they're both designed to be seen from the shooter's position without having to lift your head off the scope. The same thing would apply to a rail-mounted level, is usually offset to the side, or a ring cap level is tall enough to where it can still be seen from the shooter's position. It's important to note that if you're using a gun-mounted level, which would be those attached to the rail or the scope ring itself, that when you make adjustments to the system, you'll be adjusting the entire scope when you're making the adjustment. Whereas when you're installing and setting up a scope tube mounted level, you'll be leaving the scope alone, leaving it mounted to the system, and just making adjustments to that level itself. Personally, I prefer the scope tube mounted ones to the gun mounted ones. Now, there's a couple of reasons for that. The first and foremost is the ones that are mounted to the gun themselves, when you have to make adjustments, and some of these adjustments are really fine adjustments, you have to actually loosen the ring cap screws to adjust the scope. And especially if you're using the live fire method where you're actually shooting to test if your level is on and you need to make changes, you have to completely loosen and retorque these between shooting sessions. Okay, there's a couple reasons why I also prefer these, and the first one being it's really easy to adjust these. The gun you don't have to adjust the scope rings or the scope itself when you're setting up the system or setting it up to be level. You just make small adjustments to the actual level on the tube itself. And then secondly, and most importantly, is once this level is properly installed to this scope, and it will never change. There's no reason it ever has to come off or change or do anything. You can take this scope, dismount it, work on the rifle, put it back on. You can take this scope off of this rifle, install it on a completely separate rifle, and it will function flawlessly. If that bubble in the scope is true when you take the shot, you will have no canting error no matter how it's set up on any rifle. So that's one thing that I like, is when I install a level on a scope, it's done for the life of that scope. Most likely this vortex level will never come off of this scope. And likewise, we're going to be setting up this flip up on the next rifle over here. And once I get that set up, it'll probably never leave that rifle and it will never need changed again. Alright guys, now onto the installation of a level onto the rifle scope. One thing to note is that if you're just initially installing a rifle scope on, the placement of that rifle scope isn't really that critical. You can just eyeball it, or if you have another trick that you like to use to get the scope square to the rifle, you can do that. But when you're actually installing the level onto the scope, if you're going to be using a level, which is the purpose of this video, the necessity to have this scope square to the bore or square to the rifle is very minimal, and we'll get into that a little bit later, but you don't really have to worry about it too much. And I guess as an example, this scope has been set up on this rifle for some time and it's a heck of a shooter. And if I place my bubble here, I've got a small little just bubble out of a level here, I set on the action rails, I've actually got the rifle fairly square right there to that bubble. And then if I place this bubble on the turret cap, which is just a general reference, the bubble's actually to one side a little bit, meaning that this scope is probably not square completely to the rifle. However, I have this set up for myself so that when I'm in prone position with my cheek weld and when I shoulder the rifle, that the reticle is square to my eye. And that's more important than having everything true, is that when you look through the rifle scope, and the way you hold the rifle and the way you shoulder it and the way you place your cheek on the scope, that everything is true at that point. And again, we'll get into the later part of this video why it's not as critical to have the scope dead in line with the center of the bore. So in this case, we're not going to be actually making an adjustment to the scope and the rings themselves. We'll just be simply installing this scope level on here. And going from there, we'll kind of eyeball it. We'll try and have the level in this scope level start by matching that level that's on the turret cap. And that'll be a vague starting point for us, and then get us close enough. So let me get this installed real quick and eyeballed, and then we can go outside and go through the other methods of actually fine-tuning that level and getting it exactly precise. Okay, so there's basically three methods that you can use to fine-tune your level and your shooting system to be perfectly plumb for either your reticle or your travel, depending on what application you're using. The first of that would be the simple at-home method, which I'll go through next. Second would be a non-shooting method, but done at 100 yards, which usually can't happen at home. And then the third would be an actual live fire method, and I've got my preferences for each. The at-home method is nice because anybody can do it. You can do it before you go to the range. You can get things pretty close. And the only drawback with that is you kind of want to be discreet somewhat. You don't want to be pointing guns at your neighbors and things like that. And that method basically revolves around using vertical objects in your neighborhood or across your street or buildings that you know are true and vertical and plumb to the earth. Those can be basically window frames, sides of buildings, doors that you know are level, and it doesn't have to be real far away or anything. The whole goal is just to basically get everything lined up to the level as best as possible without having to go to the range, or if you don't have time to go to the range. So we'll do that next, and I'll show you guys how that's done. So the first thing we've got to do, number one, is make sure that the gun is unloaded. I've removed the bolt from the gun just for safety purposes. And to just make sure that you're maybe doing this in a discreet location, just so that we're not annoying our neighbors. So what I've done is I've lined up the crosshairs with my little buddy rear rest and my Harris bipod up front, so that my crosshairs are dead vertical, and I'll double check it right now. Yep. The crosshair follows the edge of the trim board on that garage almost perfectly. And what I've noticed is from our downstairs, just using the turret cap to level with, We're just a touch off to the right. The bubble's just to the right a little bit. So what I need to do is, if I was just going to be using the reticle and setting this up for reticle shooting, is just gently tap over that bubble just a touch more till it's dead level. There. Let me double check the reticle's dead true still. And it is. And at that point we'd be done, and we could just tighten down the screws if this is just going to be solely used for a holdover, and we're not going to be dialing the scope at all. Right now though, we'll double check and go through the extra step of confirming and checking to see if our elevation turret tracks identical to the reticle. And we'll start that process right now, and all we'll do is basically dial down about 24 minutes because that would get me to about 1,000 yards with 100 yards zero. And we'll just watch as we track along, watch it move. It's going to wiggle as we dial, but the finishing position should be just fine and give us an indication of whether it's tracking true or not. And we'll do that several times and repeat that process to confirm our result. "12 minutes. And there's 24 minutes. And what I've noticed is that it is tracking a little bit to the right edge. Let me go back up. So it's going down and right slightly. And confirm right there again. And yeah, we're just off to that right edge just a tiny bit. Crosshairs are true there, so that's right there. Let's try it one more time. Yep, and the same result. We're just barely off to the right edge. So to correct for that, what I would have to do so that the travel was in line would be to rotate the gun clockwise and the scope counterclockwise. So in that case, I would have to rotate the gun slightly clockwise, probably about right there. Okay, and then we'll retest. Now the reticle isn't dead true, but we'll go ahead and try this again. Go back down, back to our starting point, right there. Okay, we'll reset up right on the edge of that, right on the edge of the trim molding there. Okay, and now we will dial down. It's pretty obvious that the reticle is not true. And 24 minutes. And that tracked exactly the way it was supposed to. So in this case, if I was going to be using this scope for a dialing reticle, I would need to then slightly correct the bubble back to that position right there. Alright, now that we've finished the at-home test, I went ahead and tightened down the screws that hold on the scope level, and we're ready to go to the range and do the other two tests, or show you guys how to complete the other two tests. The first thing you need to do is to draw a straight line on a target, piece of cardboard, butcher paper, whatever works for you. Draw a nice dead straight line with a level or a straight edge, and install two aiming points on it, one at the top and one at the bottom of the target. And in this case, we're going to be shooting this 7mm Remington Magnum, and at my elevation and temperature, it requires about 23.5 minutes of angle to get from 100 yards zero to 1,000 yards. So in this case, I've drawn my aiming points about 23.5 or just barely over 23.5 inches apart, so that we can also test the scope travel while we're doing it at the same time. I'm not so concerned about where they hit vertically, but at this point we need to confirm that they're going to be correct for the windage. But it's also a bonus just to know if our scope is tracking perfectly, so that when we start working on drop data and things like that, we know if our scope moves more or less than the quarter MOA per click that it says it will. One thing that I need to stress for the next two tests is to make sure that the target, the line here and the two dots are all perfectly vertical. The best way to do that is with a plumb bob. If you don't have a plumb bob, and they can be difficult to use when it's windy and other things out there, you can also use a level that you know is true and that you can trust to set and mount the target, so that everything we do from here on out will be perfectly vertical. Okay, for the non-fire, non-shooting test, you'll want to set up the rifle just like we did at home, either in a vise or something like this that will hold it dead steady so that you can dial the turret and have it not move the rifle off of its zero or off of its aiming point. So what you'll do is when you're doing the non-shooting test, you'll start with the top dot and you'll set your scope up so that the crosshairs are dead right there. And then in our case, we'll dial down or dial up on the scope, which will move the crosshairs down 23.5 minutes. And hopefully the crosshairs will end up dead on this dot. If they do not, you'll need to make a correction with your level so that they will. If for whatever reason, let's say they travel off and to the right, okay? The travel goes to the lower and to the right. That means that the reticle is canted, or the scope's travel is in that direction. And with your level straight up and down, what you would have to do if you have a gun-mounted level, you will simply rotate the scope clockwise to correct for that. In our case, with a level that's mounted to the scope tube, all we will do is rotate the level counterclockwise, and then thus it will cause us, when we re-level the level, to move the scope to the right. And that's the method you'll use. So you'll do just the opposite with the scope level as you would the scope itself. If it's coming down and to the left, the scope's canted this direction, you will rotate the scope counterclockwise or the level clockwise slightly and retest. Okay, for the shooting test, you'll do just sort of the opposite. You'll be basically aiming and shooting at the bottom dot every time. You'll have to double check and zero your rifle probably off of this target to confirm you're dead on your zero at 100 yards. Then you'll come over and maybe shoot a small group at that dot. Then you will dial up, 23.5 minutes in our case, dial up to whatever yardage, and I prefer at least 20 minutes to really test the system. You could go all the way up to 30 minutes to really test it if you want. And you'll still be aiming and shooting at this dot, but you're hoping that the bullet impact will be in the center of this dot up here. If they impact to the right or to the left, you'll do the same thing. If the bullets are impacting to the right, that means that your scope is canted to the right, causing, as you dial your scope down, you're aiming here, as you dial your scope down, you will now be aiming, you'll be bringing the gun up and to the right, and you will hit off to the right edge if it's canted this direction. Vice versa, if you're hitting left, the scope is canted this direction too far, and you'll make the correction by either adjusting the scope clockwise or counterclockwise, depending on which side you hit on, or the level, the opposite of what the scope should go. So if your bullets impact to the right, your scope is tipped to the right, you will either need to move the scope to the left or the scope level to the right so that it will recorrect when you re-level the scope level. And just the opposite for when they hit to the left. Okay, once your gun is set up properly this way and your scope level is installed so that you're either tracking true or hitting true to where you want, your scope will not have any cant error. As long as you make your shot and that bubble is centered, you will have zero canting error. And that's probably as far as anyone really needs to go. There's some more advanced techniques and some more things that I want to discuss in the next section. Alright, one of the tricks that you guys can do is when you set up your level, you can also set it up to counteract spindrift. For those that are not familiar with spindrift, the easiest way to describe it is all of our rifle barrels have a right-hand twist, or almost all of them have a right-hand twist. And remember, as that bullet falls through the air, it's never rising or anything, it's literally falling from the second it leaves the barrel, it's spinning clockwise. And as it falls through that air column, it's literally grabbing air as it goes down and spinning like a tire would on a substrate or a surface, and it will cause it to drift to the right. Now, in most cases, in my hunting rifles, it always seems to work out to be at about a half MOA, so 5 inches at 1,000 yards of spindrift. And knowing that, we can accurately compensate for that with our scope and level system. On this target over here, there's 2 lines that I've got marked that would be what equal the amount of cant that you'd have to have pre-built into the scope and level system in order to accurately eliminate the need to adjust for the windage of spindrift. And if you're using the method of the non-shooting method, you would have your scope start at this point, and as you slid down, it would follow this right-hand blue line just slowly moving off to the right and down to your point of impact down here, or your predicted point of impact. This distance between these two dots is exactly half an inch, and which would be basically a half MOA at 100 yards, which is also a half MOA at 1,000. If you were using the firing method, you would end up needing to shoot at this dot and have your final impact happen up at this distance up here at the top. It's the same half an inch away from the top. Now again, this distance is set for my rifle, which is 23.5 MOA is what it would take to get to 1,000 yards, and at that same 1,000 yards I would need a half inch of compensation for spindrift. So now I'd like to move into the area that I feel has the most amount of misinformation and is the most misunderstood, and it's usually blown way out of proportion. And that is having to have the scope in line vertically with the center line of the bore of the rifle. I haven't addressed it yet because it doesn't really make a difference in the real world. There's several different tools out there that you can buy from several different makers that cost anywhere from $20 to $100 that all help you and stress how important it is to get the scope exactly in line with the center line of the bore. And it can be important if you're not using a level, but the fact is that if you're shooting past that 500-600 yard range, you need the level, and with the level in the system, having to have the scope in line is completely useless. And I don't want to discount people that have designed and made these tools, because they all work for their intended purpose. It's just my feeling that they don't solve a problem. The problem doesn't exist, and I'm going to try and show that to you so that you can understand in the real world that it really doesn't make all that much difference. Okay, it's going to probably take just a little bit of math here and some examples to show you what I'm talking about and why it's not that important. So for the purposes of this, let's assume a worst case scenario of either someone that can't see straight and they've got the rifle and scope completely out of alignment, or more particularly and more in the real world, let's assume a guy that likes to hold the rifle at an angle. You know, you can see that in a lot of competition shooters. David Tubbs and other guys hold the rifle at extreme angles because of comfort and the ability to hold steady. And the same thing might apply to those that have got different cheek welds or ways that they like to hold the rifle. So let's assume for this, you can see in the example that this is set up on an 8-degree cant of the rifle. It's important to note that I'm only talking about canting the rifle and not the scope. For these examples, the scope will remain vertical and the travel or the reticle will remain vertical in line with the plumb or in line with gravity. On the right side, I've drawn two lines to indicate what a 5-degree and 10-degree cant would look like. And just to show you that even with the naked eye, you'll be able to easily get within 5 degrees or much less when lining up your scope over top of your bore. So on the left-hand side, we're going to assume that the rifle is being held at an 8-degree cant, with the scope still being level and true to the earth. Okay? In this example, you'll see that the scope, which is a very standard scope above your center line of your bore, is 1.75 inches, and that's pretty close to what most rifles will be. Knowing that, when we create a circle with a radius of 1.75 inches, it ends up being a circumference of 11 inches. Now, if we break up that 11 inches into 8-degree segments, you end up with 45 segments, each of those being 0.244 inches long. And that would be basically exactly what this offset distance would be vertically from the center line of the bore to the center line of the scope. And we're just going to assume for the purposes from here on out, 1/4 of an inch. And again, this is an extreme example and a worst case scenario. Okay, before we move on to these examples, I want to point out something that might be obvious but is worth re-mentioning. No matter how the scope is set up on your rifle, it could be set up at a 45-degree angle, it's possible and completely within reason to sight in at any yardage so that when you pull the trigger, the bullet will impact at that yardage. Doesn't matter the yardage. You can literally take a sight and a scope that's all out of whack, not level, do anything with it, and actually shoot it and zero the turrets so that it hits dead on at, say, 1,000 yards. Okay, so that's worth pointing out, and as we go through these examples, it should make more sense. Okay, each of these three diagrams is zeroed. The gun is zeroed at a different yardage. First one being 100, second one being 200, and the last one being 400 yards. Keep in mind that this is from above. from the sky looking down over top of the range. Assuming we have a full 1/4 inch of error at 100 yards 0, your scope will be to the left 1/4 inch at 0 yardages. At 100, we're going to zero the gun so that the windage turret and everything hits dead on. Therefore, at 200, it would be 1/4 inch off, and it's going to grow 1/4 inch every 100 yards you go out past. Okay, all the way out to 1,000 yards, you would have 2 1/4 inches of windage error if you zero the turret at 100 yards and you were 1/4 inch off horizontally with your scope. Now, as soon as you zero at 200 yards, it starts to make drastic differences downrange. You'll see that as you go out, you get 1/8 inch error for every 100 yards you grow out. Okay, all the way out to 100 yards, you're going to only be 1 inch of windage error due to your scope being a full 1/4 inch off center and setting your windage turret at 200 yards. And then even better yet, when you set your windage turret at 400 yards and you're 1/4 inch off starting, you will finish at 800 yards at another 1/4, first 400 yards at 1/4 inch, second 400 yards another 1/4 inch, and then the last 200 you'll gain 1/8 of an inch. So you'll only be 3/8 of an inch off mathematically at 1,000 yards if you zero your windage turret to be dead on at 400. That's less than the width of this pin. It doesn't make a difference, and it's easy to solve as long as you set your windage turret farther out. Okay, keep in mind that this again is an absolute worst case scenario. Most likely you're going to get very, very close just by eyeballing it, or if you adjust your rifle for comfort and cant a little bit so it's easier for you to hold or more consistent for you to hold, it's not going to be by very much, especially probably not this much. This is also one of the reasons that I tend to set my elevation turret as well as my windage turret at longer yardage. If you have a slight error or your drop data isn't quite spot on, it's better to have your turret set at a mid-range and be a little off short and a little off long, and it's real easy to do. You can still maintain a standard 100 yard or 200 yard quote zero on your drop data, and all you do is, let's say you have a 200 yard zero and it calls for 7 MOA at 500 yards. You just simply dial your turret up to 7 MOA, shoot your group. If you need to make a click or two adjustment in your elevation, you just make that click or two and then reset your turret back to 7 MOA, and when you dial down to 0, you should be dead on or extremely close. So hopefully this information has been valuable to you. I hope it wasn't too confusing. I know that the video was long and there's a lot of information, but I hope it made it clear and understandable with what's important and what's not so that you guys can go out into the field and be confident in your equipment.